Aloha and welcome. In this lesson, we're going to be talking about flowing water light. We're going to be using a special chip this time. It's an IC chip. It's the 74HC595 IC chip. And we're going to use this uh, with one specific goal in mind, and I'll explain that in just a second. So let's go ahead and take a look here at our component list. We're going to need the usual suspects up here, the Pico, the micro USB cable, the breadboard, and we're going to need one of our 74HC595 IC chips. We're going to need the lead bar graph from our previous project. We're going to need 8 220 ohm resistors, and we're going to need a boatload of jumpers, the male-to-male end jumpers. This and the next couple of projects are going to be very, very, very messy projects. And I would suggest you take your time with these and make very sure that you put everything exactly where it is supposed to go. Try to color coordinate your cables as much as you can, especially when you're dealing with power and ground. That may keep you a little bit sane when you're going through this. So anyway, the main star of this show is going to be our IC chip here, the 74HC595. And what this allows us to do is it allows us to, well, it starts with the premise here that we have a limited number of GPIO pins. There's not an unending supply of them here. So we can use a chip like this to control multiple pins. So we can use this to control essentially 8 pins. So we need, I believe it's 3 pins in order to control this, and we can expand out to 8. So think of this as like kind of like when you use a power strip. You're taking one outlet and you're turning it into several. So yeah, so here's the explanation of it. So you need 3 ports, GPIO pins, and you can use that to control 8 ports on the chip itself. So the ones that we're using, actually, if you scroll down here, you can see it. We're going to be using 1 through 7 over here, and then we're going to use 15 over here as well. So those are going to be our parallel pins. So that's going to be the data that goes out of here. And we're going to have inputs coming in on 3 of these pins. So we'll get to that in a few minutes. So anyhow, what is going to happen is the data is going to come in and it's going to get shifted to the different pins here. So it's going to take the data in serial and in bytes, 8 bits basically in a byte, and it's going to break that up to the different pins here. So you'll see a lot of references to bit shifting in our code a bit later on. So the inputs, hold on, let's take a look at our schematics here. So we're going to be taking, if you look at this, this is pretty complicated. So we've got ground going to outer rail, we've got power going to the inner rail. So then we have, we're taking power from the inner rail and we're running it over to here, which is the first chip. I think this is pin, is that 14 or 15? Let's go back to that. That's, pin 16. So we're putting the power into pin 16. And then we're also putting power into here on the second from the bottom, which is our the MR, which is the pin 10. So if you look at the pin 10, this is the remove shift register. When this pin is in low level, the content and shift register will be cleared. So we're going to be running power to there as well. And then we've got ground. You see our ground is going over here, and we're following that into pin, let's see, this is 16, 15, 14, 13. So we're bring ground into pin 13. And that tells us enable output. When this pin is in high level, it's in high resistant mode. When it's in low level, then we're using pins 0 through 7 in output mode. So going back here, so we've got our ground ground. We've also got ground going here. It's going into pin, I believe, what pin is that here? That's going into pin 8. And pin 8, you see it's the negative electrode on the power supply. So, so we're running the ground to pin 8 over here. Then we're using the first 7 over here for our data pins. We're using pin 15 over here as a data pin as well. So we're going to be going just like that across. So we're going to be able to control using the 3 pins that we have there. We're going to be able to control the 8 pins on our flowing light, our LED bar graph there. So if you look over here, we're going to be using for data, we're using pins 21, 20, and 18. So we're going to use 3 of these, 3 of them to control those. So if we look at that, if we go, pin 21 is going to be going over here to the 3rd one up. The 3rd one up is going to be our 11 here. So when we look at 11, that's our serial shift clock. When its electrical level is rising, the serial data input register will do a shift. And then if we look over here at the next one, which is 20, which 20 corresponds with, let's see, the one, let's see, 1, 2, 3, 4. This is where your color coding really helps out. So 4 from the up, so that's going to be 12. When we look at 12, that's the parallel update output. When its electrical level is rising, it will update the parallel data output. And then our last one is going to be over here on 18, which is going to go into 1, 2, 3, 4, 5, 6th one. So 6, and 1, 2, 3, 4, 5, 6. So we're going to go on, that's going to be pin 14, and that's our serial data input. So 14 DS, that's where our data is going to be coming from right there. So on pin 18 we're using. So then if we look at our code is not that complex. So if we look at our code, well, it's, we're pulling in a library, and we've got to put this library onto our chip. So you're going to have to go in here and I'll just show you. You go to the file, then you go up to view, command palette, and you upload current file to Pico. And this, don't worry about this. This is just the hardware specific initialization and your shifters, everything. And this is going to be moving the data from that serial that we get in, and it's going to push it out into parallel. So it's going to send the bits to each of the 8 different parts. So the magic is all in the code. You're setting up the chip. You're saying we're going to be using 18, 20, and 21, as we mentioned just a minute ago. We go over here, we set up X to be 1. Then we go over here, we go from count in range of 8, which is going to go 0 to 7. And we're basically going to go through that, and we're going to do chip, we're going to shift out, and then we're doing a bitwise shift of our value at X. We're going 1. So when we do that, we start out with X is 1, and then we're going to be going to 2, then we're going to go to 4, then to 8, then 16, 32, 64, 128. So we're going to be taking these numbers, and we're going to be going to chip. We're going to do a shift out, which is going to shift all the bits and populate our, it's going to break it up into the 8 different data bits that we're sending out to that LED bar graph. So that's essentially what we're doing in here. The tricky part is going to be building this. So this is one where you really want to go ahead and look very closely. It does have a little bit of information about the the chip, so I feel free to dig into that. But this is what I'm going to be looking at now. This is really going to be a pain to do, and the next several are going to be this way, because essentially what we're trying to do, the bit shifting and everything here really isn't the star of the show. What we're trying to show is that we can take a small number of GPIO pins and control a lot more data than just that. So what we can do is we can, with those three, we can control 8 outputs. So this is very helpful. So that's what we're going to be focusing on. We're going to be focusing on the use of this chip. The chip, if you look in the center here, it's put into the dip. It's put across the dip, as is our flowing light LED bar graph. So let's go ahead and put those on. Let me quit sharing my graphic there, and I'm going to attempt to do this online. This is going to be a very slow process, so please bear with me. I'm probably going to fry some stuff here. I just know I'll fry some things. So anyways, I have a ton of, over here, I've got a ton of resistors already set up. I've got everything needed to do this. So I just need to go through here slowly and set things up. So the first thing I'll do is I will set up power and ground. So we know that we're running ground into the outer rail. So we'll go over here to our ground and we'll run that into the outer rail. And I really wish I'd wet my contacts before starting this, because it is going to be very challenging to see all this. So here we go. We've got our first one. We've got our ground into the outer rail. Next, we're going to take our 3.3 volts and we're going to put that into the inner rail. And let's see, I will go ahead and stab it right there. So now we've got our power running there. Now let's go ahead and put some chips on here so that we will know where to line them up. So we'll go ahead and we'll try to make this neat. We'll put it like at the beginning of the numbers, if we can. This is being a bit of a pain. Okay, there it goes. Nicely in. So then, this is just going to make it easier when I'm, trying to pin things. I can just look for the numbers there, and then I'll do the same over here. Let me see. Okay, yeah, I'll line these up just like that. And remember, if you do have problems, you may need to switch the orientation on these. If you look at here, you've got a small little chip, a divot in there that will tell you which way is which. You can't really see it too well, but over here at the end, there's a little dip there at the end of it. But look at that in the orientation of your wording and you'll be able to figure out which way this goes. So now that we've got our power and ground over there, let's go ahead and mimic that onto our chip itself. So I'll go ahead and grab power and ground. Actually, we've got 2 powers. So let me go ahead and do power first. So we're going to go into the rail. We're going to the first pin here on the chip. So I'll just go ahead and put it right there and put that into the power, which, remember, the power is the inner rail. Let's not make a mistake and do ground to power, power to ground. So now, yay, we've got that. Now we're going to do it again over on the second to last of the pins here. So we'll go to the second to last, and this also is going here. We are going to have a rat's nest of wiring before long. I'll just warn you now, it's going to be messy. So now let's go ahead and do our other ground wire. So our ground wire is going to be going to the 1, 2, 3, hold on, 1, 2, 3, 4th pin down. So we're going to be going, let's move this so we don't have a bad view. 1, 2, 3, 4. So it's here. So we're going in. Oh, I just lost my, or did I? No, I didn't. Sorry. So we're going in here and we're going to be going to the outer rail. Gosh, this is just hard to see when I'm using the video. Okay, so we're outer rail there. Everything is hooked up okay so far. There's not a whole lot that's been done. So before we go ahead and start putting our data lines in there, well, actually, let's just go ahead and do our data lines. Those won't be that difficult. Let's see, I'll try to pull a mid-size data line for our first one, which is going to be going from pin 21 down to the third to last pin. So let me see here, 21 is right here. 21 will stab there, and then we'll go over to, what did I say? I said the 1, 2, third from the last pin on our chip here. So let's go ahead and see what's our third to last. We know that this is the second to last, so it'll be right between these two right here. So maybe I'll just try to not crowd it so much. I'll just put it like here. So I look there, and it's the 1, 2, third pin down. Okay, so now we're going to do pin 20, and that's going to go to the 1, 2, 3, fourth pin. So 20 goes to the fourth pin there. So I'll take another mid-size pin. Well, yeah, where did I say that was going? That's going to 20. So I'll come over here and I'll just stab 20 right beside it. And then this is going to be going to, let's see, which pin is this going to? This is going to go to 1, 2, 3, 4. So I see that I have a problem here already. So I think I have a problem. Nope, I don't. 1, 2, 3, 4, yes. I couldn't see here under there, but I do have. So I'll just go over here next to the blue and stab in at the blue. So right next to it. So yeah. So that has us. So now we've got the second, third, fourth, fifth, and seventh all lined up on here. The one that we haven't done yet is the second pin in, and that's going to be controlling that 8th bit. But we'll do that in just a second. So let's see if we have everything. We have 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6, 7, 8 wires up here. Should be 1, 2, 3, 4, 5, 6, 7. So I don't think I've got. Wait, hold on. 1, 2, 3, 4, 5, 6, 7. Yeah, I've only got 7 so far. So what have I forgotten here? I don't have. Oh yeah, I'm missing the one. There's one more data line from 18. So our data line from 18, we can use a smaller one for this. So let me go over here and stab into 18. So here you go in 18, and 18 is going to go down to. Let's see, from the top, it's going to be 1, 2, third one down. So 1, 2, 3 down. So we're going over here to let me see if I can pull things out of the way here cleanly. So we're going to go to the third pin, 1, 2, 3. Let's see if I can, this is really fun. So we plug into the third pin there. I hope we didn't rip everything out in the process. So we don't have anything into pin 2, correct? That's right, because pin 2 is going to be linked to our flowing LED bar graph down there. Okay, so we've got everything except pin 2 now. So why don't we go ahead and do something about that? So pin 2, well, actually pin 2, let's do that last because I'm going to have to work around that. So let me get some short, let's see what I've got in the way of shorter runs here for shunts. Okay, we're going to go, the next ones we're going to do is we're going to do the bottom pins over here. The pins over here, they're going to connect up to our LEDs. So let's start with the first one. And let's see, the first pin is going to go, let's just go down here and make it nice. And then this one will go to the second pin down. Yeah, so this will go, if we go down here, this is going to go to the second pin right there. Okay. And actually, let me try a shorter wire for this one because I may need this blue one in a minute for a different one. So I'm just going to go over here. I'm going to go to the, what did I say? This is going from the first one here. And we're going to go down to the second from the last over here. There we go. And then we're going to take the second one over here on the chip, the IC chip, and we're going to go from that second spot. We will go over to, let's see, the third spot, or no, that will be the green. That'll be the third spot in. Yeah, so here. And from this point on, what we're doing is we're just matching them up. So we're getting closer and closer on the inside. So we can start doing at this point is simply going one further over here. And then over on this side, just going one closer. Then we do, we're here. We go over here. So it's just getting closer and closer to each other. So we're getting closer. So we've got, let's see, how many do we have now? We have one, two, three, let me see. 1, 2, 1, 2, 3, 4, 5 of them done so far. So we're going to do a couple more here. Pull this back, see where we are. Plug in here, and we'll just go over to here. And then we have one more, I believe. So we have 2 more pins to cover there. So this pin will go over to the last pin position over here. Well, not last, but the one right there. There. And then our very last one over here in the bottom, we talked about this earlier, but this one here, oops, let me stab it from the bottom. So the one that's over here, this goes over to our ground on the outside. So we're just going to put this in on the outside rail. Okay. So that's looking rat's nesty. And it's just going from the last all the way over there. And now we have one more wire to hook up. And this one goes from that second pin that we talked about up here on the top of this. So we're going to go from pin number 2 right there. We're going to run this over this mountain of scrambled cabling. We're going to go all the way over to the first one. So you can see that down there, well, hold on. Let's make sure of that. Do I actually have that? No, I think I may have made a mistake here. I may be, yeah, I may have had a parallax view there. So I'm actually in the fourth one over. So yeah, so everybody has to take a step to the right here. So what I'm going to do, this is course correcting. This is nice to know now before I plug something out and try something. So this is one of the dangers of looking at it from above and not seeing it from the side view. So once you see the side view, you realize that you're basically not plugging into the right one. So we're just going to take everybody here and move everybody over one pin to the side. So it'd be so nice if I could just pull them all out as one unit and then plug them all in as one unit, but nope, no such luck. Just going to do this painfully, slowly. And the problem is my big fat fingers can't really get in here and do it that well. So yeah, just gonna hopefully not pull all my wires out when I grab one. So here we go. There, so everybody's happy there, almost. Come on, just stab in, close enough. All right, so now we can take that blue one and go to what was the first wire. Actually, I still don't like the angle of this one right here. Let me correct. Come on, it's just not stabbing in very well. I'll put it into a different one since that's better. And now I can go ahead and take my blue end from the other one and put this into the first row there. So you've got that in the first row. So by the time you finish all this, you're like, oh my gosh, this is, finally we're done. But no, now comes the hard part. Now comes the fun that you may not remember from when we originally used our handy dandy LED bar graph, but we have a boatload of resistors to put in. And yes, our misshapen, messy things here, we're going to be running ground to these here. So we need to do it for the first 8 on this side. So we're going to be doing 8 here all together. So we don't want to have these things cross each other. So we're going to be as careful as we can. But let me go ahead and stab in over here. And I'm going to go ahead and just go on the outside down here as far as I can, just so I can make use of all this extra space we have down at the far end. And if I could just get a break here, that'd be wonderful. Okay, we can put in there. Hopefully don't end up pulling it out of the other slot. But wait, hold on, let's see. Yeah, see, I'm putting into the second slot. That's not what I'm wanting here. So let me pull it out from here and hopefully put it into the other one without messing things up. So yeah, we've got that in. So yay, 1 out of 8 done. Oh boy. All right, so that's 1 out of 8. Let's make it 2 out of 8. So we go and we plug into the space over here. I'm just going to go ahead and plug this in. Let's see, where can we put that? So I'll go ahead and put that in, maybe right there. Okay, try to keep these separate so that they don't touch each other. All righty, now we're going to take number 3, straighten out those bow-legged legs. And we're going to go ahead and put into 3 there. Put the end of it into here. Say right there, try and try. Yeah, this is not fun. I really don't like the delicate nature of these resistors because they just bend so easily. You can't tell if you've got them punched in very well. And yeah, not a lot of fun to use. So let's go ahead and get the next one plugged in. Let's try to move this out of the way so we can see better. We'll be careful when we, all right, we see that we're in over there. Okay, so we'll go next to it right here. And we'll plug in. Do we have that? This is just god awful, but it's going to work because I'm willing it to work. So that's currently in. So that's halfway, guys. This is sad and pathetic, but that's all right. So now we're going to go into the next lane over. So our next lane is right there. Okay, so got that one in. And yeah, after I'm done with this, I'm going to go ahead and straighten them out so that we're not shorting everything out. So we will look at that once I'm done here. But first things first, we have to stab them all individually. So now we go and find the next one. And we pull it apart here. That one's in. So we're getting a little bit close to here. So this is the nice thing about having that property where we can just kind of go down and move it down a bit. You know, since it's color coded, I know it needs to go into, oops, did I just put that in the wrong rail? No, I didn't. I put it in the right place. So yeah, just make sure like goes where like is. So we're plugged in again. So now we take our second to last. Please, Lord, let us through this. So we take our second to last one. And where is that going? Is that in there? Okay, yeah. So we go ahead over here. We plug in here. We also plug into the outer board. Right there is fine. Oh, if we can put that in there. So let's take a look. How many pins? Are we missing pins in here? I have a feeling that, yeah, I've screwed up again. So you can see that 50, yeah, number 49 and 48, I totally missed. I couldn't see. So 49 and 48 need to be plugged in. So over here, wait, did I miss that? Let me see. So over at 50. I've got 50 plugged in, but no, I don't have 49 and 48. So technically, I can go ahead and take this one and put it into 49, but we're going to have to shift again. So let's go and see how ugly this is going to get. So oh, this is just absolutely wonderful. So see, guys, it's not just difficult for you. It's nasty for all of us. So the problem is I don't have a lot of space to work with up here. You know, I can punch that in, but it's not going to go in very cleanly. Hold on, let me see. So I need to go into 49 and I need to get into the outside rail there. But as you can see, I am not. So I move that into the outside rail, not the inside rail, because why? Because we don't like frying things. That's why. So, okay, we've got that into 49 here. So 49, so I don't have anything in 48. So that's the problem. So what we do here is we pull the one from 47 out. We move that over here to 40. There you go. All right, so you've planted that one. Now you have to go and take the one right next to it and move that one over one as well. Just put it in right there. It doesn't matter. So yes, everything is just a god-awful mess. Nothing feels very safe here. It's pretty bad. So we're just going to go ahead and take a look and make sure that we've got these separated as best as we can. So hold on. So this one. So once we've done that, we've left two of our first pins are not filled, and that is correct. Our first two pins should not be filled. So this is the way it's supposed to be. It is not supposed to look like this rat's nest of resistors, but if it works, that's good enough for me for now. I'm not going to worry about it. I don't think they're going to short here, but yeah, if we get any strange behavior, we'll know what's going on. So anyhow, this hopefully is going to work. So let's go ahead and take a look and just make sure that our red wires are going to where the red wires are going, black wires are going where the black wires go. Yep, that looks about right. So I'm going to go ahead and do the scary thing, which is plug in and smell for bacon. Oh, and we have wires, or we have it lighting up already. So I'll go ahead and pull up the code and run the code and see if the code runs or if it dies on us here. Oh, there we go. Look at that. So expect that when you plug it in, you're going to get some lights that come on automatically. But here we go, we have it working. So again, the magic here, let's go back to what is the purpose of this project? The purpose is to show you this integrated chip. This integrated chip gives you the ability to use less of these pins and still control multiple pins over here. So we're only going to use 3 pins over here, 3 data lines to control 8 pins over on this one. So we take those bits, we send them over here, and we use the chips, the chips module, and we're able to take a value, send it in on that serial line, and it's bit shifting it and moving it onto each of the 8 different bits there. And then it's sending those signals out over to here to our LED graph, and that is providing us with these nice graphics here. So that is the project. I know that this is going to be difficult for a lot of you. I look forward to seeing your results. It's a pain. It's a pain, but what we're doing here is we're just showing the chip, and if we're going to be showing the chip, we've got the power lines, the ground lines, and everything else, and we've got the 8 data lines that we're using in it. So yeah, unfortunately, we're just going to have a lot of wiring here. So thanks for bearing with me for this long video. I hope you've enjoyed it. I hope you've learned something. If you want to do a deep dive on the bit shifting, feel free to go ahead and do that. They don't really explain their algorithms. So yeah, that's to me kind of a bummer, but that they don't really go into detail explaining, the whole bit shifting logic and everything else. But anyway, the important thing to know there is that we can take our data, we can send it, to it on, serial, and then have it bust that out into parallel and send it to the 8 bits to different, wires there. So we're taking 3 lines of communication and getting 8 out of it by changing our serial to parallel there. So anyway, I hope you've enjoyed this video. Enjoyed watching me sweat and suffer over here. Good luck with yours, and I will see you in the next video. Aloha.